Okay, hi there. Good to see you in this lesson today. So, in today's class, we would be treating the AQA GCSE Physics Foundation Tier Paper 1 questions. We would be going through all these questions together, so I would want you to stay tuned till the very end of this class. Just as we know it, we have the materials, the instructions where we need to pay attention to just before we get into the examination itself. So we would be treating the year 2024 paper. That's last year. If you're watching this video in 2025. So now we would start with question one. So question one says, Figure 1 shows a static electricity generator. So this is a static electricity generator. So what's that? It contains charges and it's supposed to tell. If you place your hand on it, it's supposed to have some kind of effect because of the kind of charges that it carries. So it says the rubber belt is turned by a motor. As the rubber belt moves, charge is transferred from the rubber belt to the metal dome. So that basically just tells us how it works. Now we have another picture here. It says figure 2 shows a student touching the metal dome of the static electricity generator. The dome is negatively charged. And now we have a question to answer. It says complete the sentence. Choose the answer from the box. So basically in this question, we're supposed to be choosing we're supposed to choose the most correct answer in the box here, and we have negative, neutral, and positive. Now, what is the question? The question says, when the student touches the negatively charged metal dome, the student's hair gain a dash charge. Okay, now because the metal dome is negatively charged. And from what we learned in class about charges, many times electrons are actually virtually all the time, electrons are the only ones that actually move from the surface. Your protons do not move, and don't forget your protons are positively charged, while your electrons are negatively charged. So in this case, if the metal dome is negatively charged, this practically means that the student's hair will gain a negative charge because negative charges are the ones that will move from one point to another. So it means our answer here would be negative charge. Yeah, I think that should be a place. Yeah, so I'm going to be some negative charge. Negative charge. So that's question one. So I'm going to be switching between the board and my screen when I have to do some calculations or maybe make some drawings or some explanations. Okay, now the next question says, it says choose the answer from the box. So practically in this part of the questions, we're just supposed to pick the most correct answer from all the options that are inside the box. Now here it says the student on the hair on the student's head stands up because the strands of hair experience forces up. Now don't forget something. We already said it is a negative charge. And if we remember in when we talk about charges, we say like charges. To write something on the board again. We said like charges, they what? They repel. So when you have a minus and a minus, there is a repulsion. And you have unlike charges, they attract. So what does that mean? A plus and a minus, they would come together. Yes. This goes, this do not go. So that's really how they work. So we move on to the next one. So it means this question here, the hair on the student's head. The hair on the student's head stands up because of the forces of repulsion. Why is it the forces of repulsion? It's forces of repulsion because they're like charges. The dome is negatively charged and the hair also carries a negative charge. So the moment there's a touch on it, and what happens? Whoosh, all the earth separates and all of that. And it becomes like this. So now we have another question here. It says, which of the following diagrams show the electric field pattern of the negatively charged metal dome? Now, basically, when we talk about the negative charge, now the negative charge, if we draw the line of forces on the negative charge, let's move forward again. Just trying to make some space for a board. So this is a positive charge, these are negative charge. And we have a line of forces like this. Usually for the positive charge actually has the arrows that indicate like something is leaving it, while the negative charge has the direction of the arrows like something is coming into it. So if you want to identify the negative charge different from the positive charge, this is the negative charge, this is the negative charge, and this is negative, and this is positive. So this is how they look like. So you just have to look for the one that look like this guy among all the options that we are given. And that looks like this guy. So this is our answer here. So this guy is our guy. So the next one will be question 5. It says this shows a negative charge dome, an earthed conductor. So this is the earthed conductor, and this is the metal dome. Now we are asked to pick from the box. It says the air between the dome and the earthed conductor in an insulator. Complete the sentence. The air between the dome and the earthed conductor has a high. So because it's an insulator, right? So what does he have? So the air in between this place would have a high resistance. And why is that? It will have a high resistance because there is no exact connection between this and this. Because if there is a connection between this and this, it will cause transfer of charges. But that is not possible. Why? Because there is a resistance that is not allowing that to happen in between these two devices. So when you have a separate two objects, one could be a conductor and one could not be, depending on the gap or depending on the distance between the two objects, it will increase the resistance and it will prevent the objects from actually getting in contact, having charges getting from one of the objects to the other object. Now the earth's conductor is moved closer to the metal dome. Now a spark jumps from the dome to the earth's conductor. And now we're asking another question. The spark jumps because the air around the charged dome has become. Now, so what are they telling us here? They're telling us here now they're bringing this guy closer to this guy, and the closer it comes, what happens? It's because we said the air causes a resistance, right? And because the air causes a resistance, so the more you close that gap, the more you are reducing the resistance. And the more you begin to reduce the resistance, it means the more you are allowing charges to go from here to here. So it means the closer you bring the objects together, you're closing up the resistance. And as you begin to close up the resistance, what happens? The air in it becomes ionized. Now, what does ionize means? It means now you will now have charges escaping because it's already so close. So because you're so close already, the charges would feel excited and they say, okay, I could just jump, and you have many of them begin to jump like that, and because they begin to jump like that, they want to get into the sky now, but because they're not yet into the guy, they're just in the atmosphere, and that's what causes the sparks. So the answer here is they become ion because the air is ionized. Now, which particles are transferred when the spark jumps from the negatively charged metal dome to the earth's conductor? Those are the electrons. So your electrons are your negatively charged particles, while your protons are your positively charged particles. But in an object, actually, your electrons are the only ones that move. So it's either your electron is going somewhere, or it's either your electron is going or your electron is remaining. So so that's really what happens when it comes to particles being transferred. So it's something like this. If you have a diagram like this, so let's say this is a circle. You have your electron somewhere here, but your proton is stuck with your neutron inside the nucleus. So the only person that really moves out is your electron. This is the only guy that moves out. This is the only guy that gets to move out. This ones, no, they cannot move out. But this ones, yes, can move out. So, and these are the electrons. So the electrons are the ones, these are the protons and neutrons. The electrons are the ones that actually can move out. So in this case, they are the electrons. Okay, now we have a problem here, a calculation problem. And the question says the potential difference between the metal dome and the Earth is 300,000 volts. When the spark jumps, there is a charge flow of 0.000002 coulomb. Calculate the energy transferred by the spark. And it told us use the equation. Now, guys, anytime you are being given an instruction, you're told to use an equation, you should use that equation because for every instruction you pay attention to, you're going to receive marks for it. So it says use the equation. What's the equation? Energy transferred, charge flow times. Energy transferred is equal to the charge flow times the potential difference. So what basically do you have to do? You just have to look for all these parameters in the question. I have to write on the board again. So energy transferred, I'm just going to repeat that, is equal to, what did we have there again? Is equal to the charge flow times the potential difference. Okay, it's equal to the charge flow times the I'm just going to say PD. That's potential difference. So we just have to look for all these things, all these parameters in the question. It's already there. They've given it to you. So you just have to go back to check. So what is the energy transferred? That's what we're asked to find, right? How do we find it? We're to use the charge flow times the potential difference. So what is the charge flow? Let's go back to the question. The potential difference between the metal dome and the earth is 300,000 volts. Okay, so we know that the potential difference is 300,000 volts, right? Okay, now that we've gotten that, what else again? When the spark jumps, there is a charge flow of 0.000002. So this is our charge flow. So we have 5 zeros there and a 300,000. So basically what we are supposed to do is a 300,000 times 0.000002. And so you are already expected to come with a calculator, a scientific calculator, because you're going to need that to do all of this. So you just have to do 300,000 times 0.000002. And you have, so by the time we plunge the figures together, we have 0.6. And since it's energy, energy is always mentioned in joules. So our answer to this question is 0.6 joules. So with that, we're done with question 1. And we move on to question 2. So now in question 2, we have another figure here. It says figure 4 shows a student putting a coin into a vending machine that sells food. The vending machine is connected to the mains electricity supply. So which of the frequency mains electricity supply in the UK? Okay, this is what we learned in our class. And our answer here is what? Our answer is 60. So our answer here is what? It's 50. So 50 is our mains electricity supply in the UK. So that's 1 mark for you. And what is the potential difference of the mains electricity supply in the UK? This is 230 volts. So the answer to this is 230 volts. Now we'll move on to the next one. It says, the vending machine identifies the value of the coin by measuring the resistance of the coin. Okay, now it's another calculation here. The machine applies a potential difference of 0.45 volts across the coin. The current in the coin is 0.75 amperes. And here here we have, okay, here we have the equation. We're told use the equation. The equation says resistance is equal to the potential difference over divided by the current. So what we just have to do is we just have to identify the potential difference, and we just have to identify the current. So once we identify the potential difference, then we just divide by the current. So what's the potential difference here? That's 0.45. What's the current here? That's 0.75. So we just have to do this and say 0.45 divided by 0.75. Again, you just have to punch it on your calculator. So I'm trying to punch it on my calculator. 0.45 divided by 0.75, which is also 0.6, just like the last calculation that we did. So just go back and So the answer to this is 0.6. So now you have to write it 0.45 divided by 0.75, and that gives you 0.6 ohms. So with that, we would stop here. I would continue in the next video. Thank you.